All right, so for one-sided limits, there's two cases in which we use these, or several different cases, but two of them are on the front, one of them's on the back here. One-sided limits, your notation is going to look something like this. You can either see x is approaching a number with a little plus sign. That means from the right. Or you can see the limit as x approaches some number from the left with a little minus sign. That just means that we follow the graph in from the correct side, whichever it says, or we plug in numbers from a certain side, which is what we're going to see on the back and the piecewise functions that we're looking at. So in the case of the special case that you see here, this is one reason we use them. In a square root function, this function is only defined from here going to the right. So it wouldn't actually make sense for us to try to find a limit as we approach it from the left because there is no function to follow as we go towards 0. So in this case, you can only approach 0 from the right-hand side. And as this says, we'd follow it down, see what it gets closer to. That function would be getting closer and closer to 2. The main reasons that we will see that we use one-sided limits is either for asymptotes, which is when they go to infinity or negative infinity. We'll see that on the back. Or we're doing piecewise functions. And with piecewise functions, you want to see if the two chunks of the function are coming together or not at that certain point. So what you see then down below here in part B is a piecewise function. It says use a graph to evaluate. I don't honestly think that that's the easiest way to do this. If you understand the restrictions that you see here, it's much easier to just plug in the numbers that you're given. So in this case, it says if x is greater than 0. So we ask ourselves, greater than 0, is that from the right or from the left? Well, greater than 0 would be approaching from the right. Less than 0 would be the section that is to the left of 0. So then in part A, if they ask me to find the limit as we approach 0 from the right, because I see that little plus sign, that means I'm literally going to take 0 and I'm going to plug it into that first section because this is the section from the right. So if I say 0 plus 1, all right, that's pretty easy. That tells me the limit as I approach 0 from the right is 1. Then if it asks me to find the limit as we approach 0 from the left, that means I'm simply going to plug that into the second equation. So that's going to be negative 0 or just 0 minus 1, in this case negative 1. And we've talked about this before, but the limit as x approaches 0 as a whole is only defined if the limit from the right and the left are the same. So if the limit from the right and the left are the same, then you write that number down, or in this case, you would say the limit does not exist because those two numbers are not the same. So we can try that again on the back real quick. On the back of this one, you see another piecewise function. This one has 3 sections to it, so we have to be careful of it. Again, we look at our restrictions and we say x is greater than 2 would be to the right of 2. X is less than 2 would be to the left of 2. This section right here, if x equals 2, that is only going to matter to us if I ask this question. What is the actual function value exactly at 2? This is one of those random little closed dots that's off somewhere else, specifically down at negative 7. So this is actually not going to have a bearing on our limit at all. So in this case, if I want to know the limit as x approaches 2 from the right, I plug that into the top section up here. 2 squared gives me 4. Limit as x approaches 2 from the left, 6 minus 2 also gives me 4. And as we've discussed before, if the limit from the left and the right are the same, then the limit as a whole is 4. The only other reason we use left and right-handed limits or one-sided limits is when you see things with vertical asymptotes here. If they ask me to say what is the limit as we approach 1 from the left, the best way to do this is to plug in decimals kind of like a table. The only thing you have to be certain of is what kind of decimals you are plugging in. So I'd ask myself what kind of number is real close to 1 but just slightly less than it because it's from the left. Well, slightly less than 1 is like 0.9. Closer than that would be 0.99. Closer even than that would be 0.999. Now there is no solid rule as to how many numbers you actually have to plug in. I suggest at least 3 to find a pattern. However, if you need more or less to find that pattern, that is up to you, as long as you are getting the pattern correctly. So I take my equation here, and in place of x, I plug in 0.9. I get out something like 19.8 or something like that. So as you can see, when we plug in these numbers are steadily getting larger as I look through them. From 18.9 to 198.99 to 1998.999. These are jumping. You're adding 9s in here, and you're also adding 9s at the end every time you add a 9 to the number that you plug in. So in a case like this, if it's getting larger and larger and larger pretty quickly, we would say that the limit is going to go ahead and go to infinity. And that's something you can confirm with a graph. If you type in the equation that they've given to you and look at your graph, you should see from the left-hand side that the function is going up to infinity. So we would handle example 4 the same way. The trickiest part to these questions is just figuring out what decimals you should plug in. In this case, if you are approaching -2 from the right, some of you will need to think of a number line and think, what kind of numbers are real close to -2 on the right-hand side? Well, if we're approaching -2 from the right, think this way. A number real close to -2 would be -1.9. And if you want to get closer, you would add 9s to that. Even closer than that would be -1.999. So again, plugging these in will let us see a pattern. This one, if you look at your y's, you even see a more obvious pattern. This time, every time you add a 9 to your number that you're plugging in, you add a 0 to the numbers that you are getting back out. So again, swiftly getting larger, 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 which means this is also going to infinity. A lot of times when you are asked to do these with vertical asymptotes, you're either going to find that it goes to infinity or negative infinity, one of the two, because that's part of the reason we use this. We plug in numbers to see if it's getting larger and larger. Nothing is ever going to give you infinity directly out. Now, if you do something like example 5, this is just an old review. Notice that they don't have from the right or the left there. I can't plug -2 directly into that, so I could check the right and the left if I wanted to plug in decimals. But we all know already that the easier way to do that is to simply factor your equation and see what cancels out. The bottom factors into x plus 2, x minus 2. And if we're careful on this and cancel that out, that should leave us a 1 over x minus 2, which I can then take and plug my -2 into, giving me a limit of -1/4. Now the last one I want to talk about, example 6 here, is just to talk about plugging in numbers that are close to pi. First off, because you're plugging in numbers close to pi, you're going to want to be in radians for this. Radians pretty much for this whole chapter. I haven't seen any yet with degrees. But we have to think carefully if we are approaching pi from the left. Well, pi is 3.14. A decimal that is slightly smaller than that, so coming from the left would be like 3.13. But the closer we want to get to that, we would add 9s to that. So I'd plug in 3.13, 3.139, 3.1399, and so on, and see what we get back out. So as you can see with this one, there's less of a pattern. However, it does become more and more negative as we go through these. This one's a little bit harder to see. You might want to, if you run a quiz or a test, check the graph to make sure that you know what you're doing on this one. But as you do approach pi on this one from the left, this should be going to something what we would consider negative infinity. Again, the larger the numbers get, the quicker. That would be more of an indication for infinity or negative infinity, but this one, it's a little bit harder to see. So for your homework for this, it's on, I believe, 402 and 403 in your notebook. So on page 402 and 403, you're going to do 2 sections. Numbers 9 through, I believe it is 23 odds. And then numbers on 403, I think it's 33 through 43 odds. Let me double check that on the next page here. Yes, starting at 33. So we have 2 sections to this. The first section is the piecewise functions that we started with in our notes. And just to kind of show you one of these, if we look at number 11 real quick, if you notice in the directions on this section, they say they want you to find the limit from the right, from the left, and then the limit as a whole. So in a case like example, or number 11 here, you are going to find the limit as you approach this number 6 from the left, 6 from the right, and then see if there's a limit if they match. So in this case, this is similar to that second example we did with the piecewise functions. You just want to make sure you're reading the restrictions. If I want to approach 6 from the left, I need to find the section that says something specifically about x is less than 6. So in this case, this right here tells me x is less than or equal to 6. This over here, that first one, doesn't say anything about 6, so I'm actually not going to even worry about that section. That has to do with 2. I'm not finding the limit as we approach 2, only 6 on this one, because that's what it gave me. So as I approach 6 from the left, that would be specifically 2, because I can't plug anything in. As I approach 6 from the right, this section tells me x is greater than 6. I would plug in 6 here. 14 minus 2 times 6 also gives me 2. If the limit from the left and the right are both 2, then the limit as a whole is 2. And you can write those kind of answers with that notation there as you go through that section. The other section down here, 33 through 43, is where we start doing the decimals. So for something like 33, we want to approach 2 from the right. I'd ask myself, well, what kind of decimal is slightly larger than 2? Well, something like 2.1. If I want to get closer to 2 from the right, I add zeros. So like 2.01 or 2.001 and so on. Again, only plug in as many as you need to find a pattern and see what it's getting closer to. If you have any questions, please come see me and I'll be happy to help.